Hi everyone. All right, we are on to the practice final. We're almost there. So I'm just going to go through these problems. There's 50 of them. Let me make sure I'm going to pull out the answer key, make sure I don't find any mistakes along the way, and go through this. Okay. So first up, calculate the volume occupied by 25.2 grams of carbon dioxide at 0.85 atmospheres and 25 degrees Celsius. So when I have a bunch of information about a gas, I need the ideal gas law. And what I'm looking for is the volume, so I'll solve for that. And then I need to just plug everything in. Okay, so I need the amount of gas in moles. I have it right now in grams, so I'll convert that. Using the molar mass, I will look up the mass of carbon and 2 oxygens, which is 44. And 0.573 moles. The gas constant, there's 2 versions on the equation sheet. This is the only one we're going to be using in this class. We use the other one in Chem 2. I need to put my temperature into Kelvin. It's 25 degrees Celsius, so 298 Kelvin. And my pressure. So I just kept my old answer. And I get 16.68 liters, so that looks like about 16.9, so slight rounding difference, but close enough. For the next one, which is element is being oxidized in the following chemical reaction. So I remember this by the thing where the charge is going up. One place that's easy to look first is at any element that's by itself, because I know that's a 0, and on the other side it's part of a molecule, so it's not a 0 anymore. And I see there's 2 nitrates attached to the copper. Excuse me. Those are -1 each, so that's a total of -2, so that means the copper must be +2 to cancel that out, and so it went from 0 to +2, so that's it. Copper was oxidized. Balancing equations, I can start from kind of wherever I want to. I guess I'll just start at the beginning. I've got 1 phosphorus here, 1 phosphorus over here, 3 chlorines. I had 1 chlorine, so I'll have 3 chlorines now. I've got, let's see, 2 hydrogen over here, but here I've got 3 and 3, that's 6, so I would need 6. And then 3 oxygen, so that looks pretty good. And so remember, these blank spaces are 1s. And so what is the coefficient in front of water? It would be 3. All right, and next up, DEET is the active ingredient in mosquito repellents. What's the hybridization state of the carbon indicated? Okay, so this carbon, I want to redraw this a little so it looks more like this, right? Because those are 2 things attached by bonds, and now I can clearly see that there's 4 electron groups. 4 electron groups means I need an S and 3 Ps. All right, that's page 1. Moving on to page 2. Okay, express the number in scientific notation. I only need to move the decimal 1 place, so 2.67, and so 10 to the just first power. The mass of, so notice there's a mix in here of longer problems and shorter problems. Like this gas one, the very first one, was kind of long. I had to do a few different conversions before I plugged it in, and then I've gone through some fast ones. So you will have 50 questions and 2 hours, so just, remember that it's okay to spend time on the ones that do take a little longer, and it's okay for some of them to not be so long. Okay, 1.21 times 10 to the 20th atoms of sulfur. First thing I'm going to need to do is convert that to moles. I'll use Avogadro's number. And then it asks me to get all the way to mass, so I will need the mass of sulfur is 32.07. Remember, that means 32.07 grams per 1 mole. So put this in my calculator, 1 times 10 to the 20th times 32.07. I'm just multiplying through what's on top, divided by 6.022 times 10 to the 23rd. And I get 6.44 times 10. Okay, wait a minute. Oh, whoop, I missed a number right here. I missed a 20. So let's do a 0. Ah, there we go. All right, so now I got 0.00644. And that doesn't match any of my choices. It looks kind of like this last one though. So when I look at the units, this would be grams. And so if I convert, this is in milligrams. So if I convert it, 1, 2, 3, yep, sure enough, that is the same. All right, what is the wavelength of radiation? Okay, wavelength. So this is C equals lambda nu. I want to solve for wavelength, so I'm going to divide by nu. I need the speed of light, 3 times 10 to the 8th meters per second, and divide it by 5.39 times 10 to the 14th inverse seconds. All right, I got like a bunch of zeros, so I'm going to convert it to scientific notation, and I get 5.57 times 10 to the minus 7th. The answer should be in meters, right? The seconds canceled. And I'm in meters. It looks like all my choices are in nanometers, so I can just go ahead and multiply that by 1 times 10 to the 9th. And I get that. Now it's a tiny exponent, so I can convert it 557 nanometers. 556. All right, 0 degrees Fahrenheit, express this temperature in Celsius. Okay, let me pull out my equation sheet. So remember, you will have access to the same equation sheet as you had for the midterm, and it does have the relationships between the various temperatures. I have a temperature in Fahrenheit. I want an answer in Celsius, so I'm going to choose this one here where it's already solved for Celsius. Jeez Louise. There we go. Some of the stuff on here is just to cancel the units, but basically I just need to subtract 32, multiply by 5 over 9. I'm going to leave the units off, actually. This is one where I think they're not as helpful. So negative 32 times 5 divided by 9 is negative, I got negative 17.777, so I'll round that to 2 sig figs. I get negative 18. That looks like my choices. All right, which of the following pairs are isoelectronic? Remember, isoelectronic means they have the same electron configuration. So I need my periodic table for this. And so I have, let's see, zinc and copper. Whoa, sorry, I can't see those. All right, I'm going to cover up the question. Hopefully you have that in front of you. I'll show the periodic table on the screen. All right, so zinc 2+ and copper 2+. Well, they're not isoelectronic now, so if you take 2 electrons away from both of them, I don't think those could be isoelectronic either. I've got chlorine minus and sulfur. So chlorine minus would have 1 extra electron. It would be like argon, not like sulfur, so not that one. Manganese 2+ and argon. Manganese losing 2 electrons would only take it back a little bit, so that's not it. Potassium plus, which would take it back to the previous noble gas, argon, and chlorine minus, which would take it up 1 to argon. So that looks the best so far. And circle that as my answer. I think that's right. And then I have 1 choice left, sodium and potassium plus. So these would both lose 1 and become a noble gas, but they would become 2 different noble gases. So that's not it either. So potassium plus, chlorine minus would have the exact same electron configuration, and that is the answer. All right, page 3. Sorry, stack my papers here. All right, which one of the following would have the largest radius? Okay, so now we're looking at sodium plus, which would be like neon. oxygen 2 minus, which would be like neon, potassium plus, which would be like, potassium plus, which would be like argon. So that's bigger than neon. So far that would be it. So I can cross these other ones off, right? Like I can cross those two. Sulfur 2 minus would be like argon, and chlorine minus would be like argon. So it's one of these. Remember that when you lose electrons, like potassium would be doing, it gets smaller, and when you gain electrons, it gets bigger. So chlorine or sulfur would be the ones that would get bigger. And since sulfur is gaining 2 electrons, that would be the biggest bigger. All right, boron, 2 isotopes, boron 10 and boron 11, atomic mass is 10.013 and 11.09 AMU. The mass of boron is 10.81. Which isotope is more abundant? So I could think of this a few different ways, but well, maybe not. It's closer to this, right? Like it's closer to 11. If it was exactly half and half, it would be about 10.5. And it's a little higher than that, so it must be mostly boron 11. Which one of the following is most likely to be an ionic compound? Ionic compounds include a metal. So if I start pulling out my periodic table, let me just pull this up so I don't have to keep sliding it. All right, there we go. All right, so I've got iron and chlorine. Iron looks like a metal, so that looks like a possibility. S and O, sulfur and oxygen, both nonmetals. Chlorine and fluorine, both nonmetals. Nitrogen and hydrogen, both nonmetals. Phosphorus and fluorine, both nonmetals. So it was that first one. The iron is the only metal there. All right, what is the molar mass of nicotine? C10. So I'm just gonna, since I got it here, I'm just gonna keep it here. C is 10 times 12.01. Hydrogen, I've got 14 times 1.008. AMU, grams per mole. Remember, one is just the mass of an atom, one is the mass of a mole. The units are different, but they're the same number, so it doesn't matter. I see now they're actually, the answers are in grams per mole, but. And then 2 times 14.00, 14.01. There we go, 2 times. All right, so just put that in my calculator. I'm going to put it with parentheses so I can just do it all in one go. 10 times, I'm going to actually, well, all right, 12.01, 14 times 1.008, 2 times 14.01. 162.2, which is E. You can see none of these had decimal places, so I could have probably rounded these all to whole numbers as well and saved myself a couple of buttons, and I would have gotten the same answer. So either way is fine. All right, the number of pi bonds in the molecule below. Remember, the first set is a sigma. The first of a set is a sigma. And so a double bond has 1 sigma, 1 pi, and a triple bond has 1 sigma and 2 pi. So I've got a double and a triple, so I've got 3. This is clear. Okay. Predict the geometry and polarity for CS2. All right, so I'm going to need to draw it in order to figure both of those things out. So I'm going to start with putting the least electronegative in the middle. That looks like it should be carbon to me, right? Carbon is further from fluorine. Sulfur is pretty close, so I think it should be carbon. Complete the octet on everything. Add up how many electrons I should have. This is from the periodic table. 4 valence electrons for carbon, 6 for sulfur. So I should have 16. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm going to need some double bonds. I'll put one in on each side. 2, 4, 6, 8, 10, 12, 14, 16. And so that looks like what it should be. So this has no lone pairs left on the central atom, which means it should be linear. Tetrahedral is never an option. There are only two things attached, but bent could have been an option if there were lone pairs. It's not. There are no lone pairs. And then assuming these are assuming these are polar bonds, they will cancel out anyway, so it doesn't matter. So it would be a nonpolar molecule whether they're polar or not. There we go. Sorry to focus that a little better. Okay. Kilometers into micrometers. All right, so 6.0 kilometers. I do need to know the conversion, or I can use the things here, but I prefer just to say 1,000, no, I already said it wrong. 1 kilometer is 1,000 meters. I know there's more meters, like meters are smaller than kilometers, so even though I started to write it wrong, my brain cued me in. Otherwise, you can use the equation sheet. And then 1 meter, it tells me, is 10 to the 6th micrometers. And so I will take my 6 times 1,000 times 1 times 10 to the 6th. Get tons of zeros, so I'll convert it so I don't have to count them all. And I get 6 times 10 to the 9th, which is C. Which of the following atoms does not participate in hydrogen bonding? It's sulfur. Remember that the ones that participate in hydrogen bonding are these little guys up here that are pretty electronegative, N, O, and F. So that's it. What is the energy of 1 photon? Okay, so here's the wavelength. It's giving me the wavelength, and I need to calculate the energy. So first I need to figure out the frequency, because remember the energy equation is h times the frequency. So I'll need to figure that out first. So if my wavelength, they're often given in nanometers. If it was given in nanometers, I would need to be sure to convert it to meters, but this one is already in meters, so I'm good there. So I just need to divide. And then I can take that and plug it in down here. Remember, this is on your equation sheet here. And my number already typed in from before, times Planck's constant. To the following sets of quantum numbers is not possible. All right, so I need to, usually I would just look at all the n's, they all look fine. Then I can move on to the l's. They can be from 0 up to n minus 1, so this could be 0, 1, or 2, fine. 0 or 1, fine. 0, 1, or 2, 0 or 1, fine. 0, 1, or 2, fine. 0, 1, 2, 3, fine. The m sub l's can be anywhere from plus L to minus L. So here, if it's 0, it needs to be 0, so that looks like the problem. That one's fine, fine, fine. That one's fine, and then these all have to be plus or minus a half. So those are fine as well. So it's just that one right there. All right, give the number of lone pairs around the central atom in the geometry of ClO3. All right, so again, I'm going to start with setting it up as best I can. Complete the octet on everything. Figure out how many electrons I'm allowed to have from the periodic table. 7 for chlorine, 3 for oxygen, and there are 3 of those. The negative sign means an extra 1, so 18 plus 8 is 26. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I have 26, so I'm good. I can mark it as an ion if I want to. Okay, So how many lone pairs on the central atom? 1. And then hopefully I can identify this as trigonopyramidal, not bent because there's too many atoms attached for it to be bent, but 3 bonds, 1 lone pair is trigonopyramidal. What is the limiting reagent in the reaction below? Okay, so I need to, basically I'm just going to figure out, I'm going to pick a product, it doesn't matter, to convert it to. And so I can convert both of these to how much could I make of that product, and then we'll see what happens. So I need the molar mass, my periodic table here. Chromium is 52, got 2 of those, and 3 oxygens. So 152 for the molar mass. And then I need the mole ratio for whatever I'm in now, Cr2O3, to what I want to get to. And I don't even really need to go to grams. I'll just leave it in moles. We can convert, as long as we have the same unit to compare, we can leave it. So I'll just do this. Then I do the same thing for aluminum. And I look at the mole ratio, and it's 2 to 2, so 2 moles of aluminum. Remember, I want the same end point, so I want chromium again. 8 times 2 divided by 27 divided by 2. And I got 0.296. Okay, so if I use up all the chromium oxide, I could make 0.526 moles of chromium. If I use up all the aluminum, I could make 0.296 moles of chromium. So that's it. That's all I can make. I will run out of aluminum first. All right, how many silicon atoms are there in 1 gram of silicon? We did a problem like this earlier where we converted atoms to grams. Now we're going to go backwards. So 1 gram 28.09 is the molar mass. I looked that up on the periodic table, and then I just need Avogadro's number. And I'm setting this up so my units will cancel. So moles on the bottom this time, 6.022 times 10 to the 23rd. Oops. So 1 times 6.022 times 10 to the 23rd divided by 28.09, and that's it. All right, density. It tells me the density, it tells me the grams, and it asks for the volume. So I'm going to go ahead and solve this for volume first. So I need to get volume on top and by itself. So volume equals mass divided by density. And the mass is 55.85. Density is 7.86. I got 7.105, so I rounded that 7.11 centimeters in the denominator of the denominator become the numerator, so 7.11 centimeters cubed. And so. All right, electron configuration for the iron ion. First I'm going to do the electron configuration of, iron, not fluorine. So iron, noble gas before it is argon. Pull this up again. All right, so argon, and then I'm at 4s2, and I go across that. And then 1, 2, 3, 4, 5, 6. So that's for just straight up iron. Iron 3 plus, I would take away all of my S's and one of my D's. I have to take away 3, and I start by taking away the S's. So argon's still there, 3D5. All right, which of the following elements has the highest first ionization energy? So remember, ionization energy is how much energy does it take to remove an electron. So, all right, let me see if I can show this. All right, so we've got oxygen. Okay, well, let's talk about the trend. So it's harder to remove an electron if it is smaller. So higher up on the periodic table, we'll have a higher first ionization energy because they're smaller. And then the things that want to keep their electrons and gain more electrons are going to be less likely to give them up. So over here on the right-hand side, we'll have higher first ionization energy than on the left. Okay, so oxygen looks pretty high. Phosphorus, lower and to the left, so that should be lower. Selenium, lower and, well, just lower, but that's enough. Germanium, lower and to the left. Carbon to the left. So it looks like it was oxygen. All right, air contains 78% nitrogen, 21% oxygen, 1% argon by volume, total atmosphere of total pressure of 1 atmosphere. Which gas will have the highest partial pressure? I could actually figure them out if I needed to, but I don't need to. Whichever one has the highest percent will have the highest partial pressure. The amount of heat necessary. All right, so this is a Q equals ms delta T. Is just, let me readjust so you can read it. This is just changing the temperature of a thing, not a chemical reaction. So Q equals ms delta T. All right, so 12 grams is my mass. The specific heat is given to me, 4.18 joules on top, grams and degrees Celsius on the bottom. And then the delta T is the change in temperature, final minus initial, so 93 minus 15.4. Is my change in temperature. So I'll just multiply that up together. 3892.4. My units here would be joules. You can see that that doesn't exactly match any of my answers, but to 3 sig figs, 3890 joules, it does. All right, which one of the following acids is a chlorine? Ooh, in the +5 oxidation state. Okay, so remember for oxidation state, hydrogen is always +1. Oxygen is always -2, and then I just use how many I have of each of those to figure out what the chlorine must be. So this is +1 and -6, so actually that looks like the answer. That looks like +5. But let me check the rest. +1 and -4, so the chlorine must be +3. Here, let me just write it. All right, +1, and so the chlorine must be -1. +1 and -8, so the chlorine must be +7. And then +1 and -2, so the chlorine must be +1. So it was that first one. All right, what mass is needed to prepare 200 milliliters of a solution having a potassium ion concentration of 0.150 molar? All right, those are the few things involved here. One is I can figure out how many moles of potassium carbonate will be in here. So let me just worry about the moles part first. So remember, this is 0.150 moles per liter. That's what molarity means. So I can convert this to liters and make my liters cancel by multiplying. All right, so that's how many moles I need of the whole thing. This one's tricky. because now I need to think about what happens when I put this in solution. It will separate into 2 potassiums and 1 carbonate, right? So if I put in 0.03 moles of this, I would get 0.03 moles of this, but I'll get double it because of the 2.06 moles of this. Oh, so I should have used that. Yeah, sorry, I should go back. Cancel it all. Let's start from 0.150 molar, because it was the molarity. That was about the potassium ion, not the moles. So I need to go back to here. So 0.15 molar of this, but 0.3 molar of the potassium ion. So that's the concentration I want to plug in here, not 0.15. And so this would be 0.060. Okay, so I hope that makes sense. Because it was the molarity, I forgot where the potassium ion was mentioned. The potassium ion solution concentration. No, I'm still messed up. Oh my goodness. The potassium ion concentration is 0.150 molar. Oh my goodness. If you're confused on this one, I'm right there with you. All right, so this is what's 0.15 molar. So these are half. This is what I plug in here. All right, we're going to get there. 0.075, because this is 0.15 molar. I need to just read my question more carefully before I start. Good advice for every test taker, right? Excuse me. All right, so then these are half, because this is what I want to figure out the moles of. That's the number I want to use. 200 milliliters of this concentration of the whole thing gives me 0.06. No, that wasn't done. 0.015. And that's what I now need to convert to grams, because what it actually asked me for is grams. Oy, boy, boy. Okay. It's of the whole thing. So now I need to get the molar mass of potassium, 39.1, carbon, and 3 oxygens, 138.2. That's my grams, so that goes on top. So it cancels with moles. Multiply it by the 0.015, and I get 2.07. Which is grams of potassium carbonate. Whew. All right, which of the following is the most electronegative? Remember, the most electronegative element on the periodic table is, sorry, let me adjust here. There we go, maybe. Fluorine, so I'm looking for it to be close to fluorine. So arsenic is down here. Phosphorus is above it, so that would be higher electronegativity, so I can cross out arsenic. Lithium is way over here. It's a row up, but it is way over. So I would say phosphorus looks more electronegative. Remember, the metals are low electronegativity, so I'm going to say no to that one. Germanium is below phosphorus and to the left, so that's not it. And then cesium is way over here. Also not it. So phosphorus looks like the winner. All right, the number of lone pairs on this, the number of lone pairs in the NO2 minus ion. All right, so NO. Remember, nitrogen is a little less electronegative than oxygen, so it should go in the middle. Complete the octet on everything. Count up my electrons. 5 from nitrogen, 6 times 2 is 12 from oxygen, and 1 from the negative sign, so that would be a total of 18. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, so I need to put in 1 double bond, which leaves me with 1, 2, 3, 4, 5, 6 lone pairs. Two isotopes. Remember, that means that they have different number of neutrons. That's what an isotope is. That's my first thought, which is not one of the choices. So what would that change? It would not change their atomic number. It doesn't change their symbol. I think symbol meaning like calcium, like Ca. Doesn't change their protons or electrons. It does change their atomic mass. Remember that mass number on top is what changes. And that's what these masses on here are, a combination of all the different isotopes. So it would be that. All right, the orbital diagram for ground state nitrogen. Let me just write the electron configuration for nitrogen. So it's right here. It would have helium, and then 2s2, 2p, 1, 2, 3. I would start from there. Okay, well, they all have 1s instead of helium, so that's the same. So 1s2. Let me just, sometimes I find it easier to just write it myself and then see which one matches. So 2s2 and then 2p3. Remember, there's 3 p orbitals always, and then you put one line on each. So that looks like B. The problem with A is that there's not an electron here. This one has too many electrons, and then this one, we paired them up before the last line was full. We want to put one per line first. Okay, sample of nitrogen occupies 2.4 liters, 20. Okay, so we're looking for a change in volume and temperature. And I have my two volumes. B1, T1, and B2, and I want to solve for T2. Remember that that means it has to be by itself, but also on top, so I'm going to cross multiply. So I get it all on one line, and then I can get T2 by itself. You can see they're all scrambled together. That's why I like to just have everything labeled up front. 4.80 liters. The only other thing I need to do is remember that in gases, temperatures always have to be in Kelvin. So 293. I get 586. Now that's not one of my choices. None of the answers are in Kelvin, so I'm going to have to subtract off 273 to get it into Celsius. But that is not the same as just doing it in Celsius. So let me just show you. 4.8 times 20, if I plug in the Celsius temperature, 4.8 times 20 divided by 2.4 gives me a totally different number. Way different, right? 40 degrees is nowhere close to 313 degrees, which is the correct answer. So just make sure you remember to convert and then convert back if necessary. 35, we're getting there. All right, so I'm looking for the standard enthalpy change for this reaction given these two. So what I want to do is look for all my parts and get everything else to cancel. So I have two C8H18s on the left, and here I've got that as well. So I'm going to copy this one. I'll just copy it. I'm dropping my phases just for conciseness. And then I need, okay, what else do I need? What else do I need that's not in this equation? So oxygen's in here, water's in here, carbon monoxide. I need 16 of those on the right. So I need to take this one, I have it on the left here. I need to flip it and multiply by 8. Oh, so then multiply by 8, 16 CO2 on the left, and then 16 CO plus 8 O2 on the right. Change the sign, this becomes positive, and multiply it by 8. 5, 6, 6 times 8. 4, 5, 2, 8. All right, so does that work? 16 CO2s cancel. I've got 8 oxygen over here and 25 oxygen over here, so 8 of them cancel, which leaves me with 17, which gives me 2 C8H18. 17 oxygen, 16 carbon monoxide, and 18 water. Looks great, so then I just add this up. Oh, I missed a number, dang it. There we go. So negative 6492 kilojoules per mole. How many significant figures does the following sum contain? All right, so first I'm just going to put it in my calculator, add them up, check my work because I've been missing my numbers. That's what I get. I want to round to, remember for addition, it's based on decimal places. This one has 2 decimal places, this one has 4, so I want to round it to 2, which means it would be 10.45, which is 4 significant figures. Magnesium ion, remember, I can look at the periodic table for how many protons it has, which is 12. That never changes. If it was neutral, it would have 12 electrons, but here it's a +2, which means it's missing 2 electrons, so it would have 10 electrons. All right, how many molecules are present in one 500 milligram tablet of aspirin? All right, I went ahead and just converted it to grams in my head because I know I'm going to need it in grams when I use the molar mass. Now I'm going to figure out the molar mass. 12 times 9 for carbon, 8 times 1 for hydrogen, 4 times 16 for oxygen. So that's moles. I need it in molecules, so multiply by Avogadro's number. .67 times 10 to the 24th molecules. I did not get the same answer as the answer key. Did I do it right? Okay, hold on. 6.022 times 10 to the 23rd divided by 180. Oh, I don't know what I did. It is 1.67 times 10 to the 21st with exactly the work as we did it, so I'm not sure what I did the first time. Okay, there we go. All right, what is the formal charge on sulfur in the best Lewis structure for SCN minus? Carbon is the least electronegative of those 3, so I'll put that in the middle. Complete the octet on everything. For formal charge, I need a Lewis structure. Add up my electrons, 6, 4, 5, and 1, so 16, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm going to have to put in 2 double bonds. I can think I could do, okay, let me just do the options. All right, so I put it in 3 different ways, right? I could put a triple bond on one side, triple bond on the other side, or 2 double bonds, and then I completed the octet on everything based on that. All of these hopefully have 16. 2, 4, 6, 8, 10, 12, 14, 16, 2, 4, 6, 8, 10, 12, 14, 16, 2, 4, 6, 8, 10, 12, 14, 16. Okay, then I'm going to figure out the formal charge on everything because I don't know which one of these is the best one yet, and then we'll put the answer. All right, so formal charge on everything. I'm going to do all the sulfurs first. Remember, formal charge is 6 from the periodic table, -1 for every dot, -1 for every line. So that's plus 1. 6 minus 6 is 0. 6 minus 7 is minus 1. Carbon, 4 from the periodic table, minus 1 for every dot, 1 for every line. That's 0, 0, and 0 because they all have 4 lines. Nitrogen is 5 from the periodic table, minus 1 for every dot and 1 for every line. So that's minus 2, minus 1, and 0. Okay, so I can cross this one off immediately, and then between these two, I need to decide which one is better. And so I need to know the negative should be on the more electronegative element. This one's a tough one. This would be a hard one for an exam because sulfur and nitrogen are very similar in it's hard to guess the electronegativity. I honestly don't even know off the top of my own head. So I would say this is a little bit too tricky for I don't know if you can see it, but because they're both pretty close to fluorine, like this is 2 away, this is down 1 and to the left. I think that's a little bit outside of what I would expect you to know on an exam. So it's either -1 or 0. It looks like the correct answer is the one where the sulfur is the 0 and the nitrogen is the -1. That was my guess, but I really didn't know that one. But that's the idea, and hopefully on the exam, not hopefully, I write the exam, I will write it more fairly, but so that you would be able to pick without having any more information. All right. Number 40. Okay, we did this. We did a question just like this. Let's go back to our work on this one. It says, what is the theoretical yield of chromium? Oh, and look at that. I actually already made it all the way to moles of chromium. This is the exact same problem. So I can start from this answer here that I circled. I need to know the limiting reagent, but since I already did that, now I can just convert that to grams of chromium. And I should have my answer. So that was lucky. All right, the Lewis dot symbol for the chloride ion is showing all of the electrons and the negative sign. Chlorine itself would have 7 electrons. Chloride ion would have 1 extra, so it would have 8. All right, solubility rules. Which of the following is insoluble in water? Okay, so for my solubility rules, I would always start with memorizing the alkali metal rules because alkali metals are always soluble, no exceptions. Potassium is an alkali metal. Sodium is an alkali metal. Potassium is an alkali metal. Oh yeah, and with that, alkali metals plus ammonia. Ammonia, always soluble, no exceptions. So even if I'm not sure why calcium carbonate wouldn't be, I know that's the answer because the other ones are always soluble, no exceptions. All right, how many sulfur atoms are there in 21 grams of Al2S3? I'm going to have to convert it to moles using the molar mass. Let me just... do 2.07. Okay. All right, so 27 twice, 2.07, 3 times is 150.21. That's the moles of the whole thing. Now I can go straight from that to 3 moles of sulfur in each one, right? So because every molecule has 3 sulfurs, and then I can go from there. You could put these in a different order and think about them a little differently and still get the right answer. If you have the same factors in the same general area, so. All right, last page, this is it. What would the net ionic equation be when PbNO3 and NH4Cl are mixed. Solution, so I know they're aqueous. What would happen? The ammonium and the nitrate would bond together. They're both plus and minus 1, so they would go like that, one of each. And then the lead and the chlorine would go together. Lead is plus 2, I can tell because of the nitrate, and chlorine is minus 1, so it would be like that. You can balance it like that. Ammonium, always soluble, no exceptions. Nitrate, always soluble, no exceptions. Chlorine, usually soluble, but lead is one of my exceptions, so that is a solid. So then I would separate all of these into ions if they're aqueous. And then I would leave, okay, so sorry I did that without talking, but the nitrate, the 2 comes out in front, the 2 here goes to both things, so 2 ammoniums and 2 chlorines because each one has 1 and all that good stuff. Same thing over here, separate, the 2 goes to both, but then the lead chloride stays the same because that's a solid and it does not cancel. So I've got the nitrates cancel, the ammoniums cancel, and what's left is my net ionic. So lead, chlorine, and lead chloride. And that looks like D. All right, a 50 milliliter sample of 0.436 molar ammonium nitrate is diluted with water. Total volume of 250. What's the concentrate? Okay, so this is an M1V1 equals M2V2. This is how we do dilutions. And I just went ahead and labeled everything as M1, V1, V2, and M2 is what I'm solving for, so I'll get that by itself. And here we go. I can leave this in milliliters. Okay, so I'm doing M1 times V1 divided by V2. Me and my calculator today. All right, so I got 0.0872. Let's see, I should have about 3 sig figs, 4 sig figs. So I should have 0. Oh, that's it. That is 3 sig figs. And that's molar. So milliliters cancel. That looks like it should be this if I move the decimal 2 places. All right, pressure. I need a conversion factor between millimeters of mercury and kilopascals. If I look at my equation sheet, I do not find one, but I do find pascals in millimeters of mercury, so I can use that. Just setting it up so the units will cancel. 1.1325 pascals. And then I know that the prefix means 1,000 pascals per 1 kilopascal. Even if I've never heard of that unit, I can figure out what that prefix must be, what that must mean. Oops, divided by 760. All right, ethanol, how much heat is released when 1 mole of ethanol burns? Okay, so here's the reaction and here's how much heat. The negative means it's released. This is per 1 reaction, and 1 reaction is 1 ethanol, so that's it. 1,367 kilojoules of heat are released. How many iron atoms are present in 1 molecule of iron 2 oxide? Remember that means iron is 2 plus. Oxygen from the periodic table is always 2 minus. So to make it balanced, it would be 1 of each. All All right, which one of the following is most likely to be a covalent compound? We did a previous example where we were looking for an ionic compound. Remember that needed a metal. This one we want no metal. So we've got rubidium, that's a metal, gone. Barium, that's a metal, gone. Strontium, that's a metal, gone. Selenium and oxygen are both over here, so that looks promising. And the manganese, that's a metal, gone. So it would be the selenium oxide. Which of the following has the ground state electron configuration? Okay, so I'm just gonna use my marker to or use my pen to indicate where I'm at. Krypton, and then 5s2, 4d10 all the way across here, and then 5p3, 1, 2, 3, and I'm at antimony. And last but not least, calcium and nitrate ions. Calcium from the periodic table is +2, nitrate. Hopefully by now you know the polyatomic ions, or at least most of them, you know which ones are most important, so you can get a feel for that. Because you need to know that it's a -1, then I can put them together to make it neutral. That would be 1 calcium and 2 nitrates. Okay, that's it. That's the practice exam for the final. Good luck. Let me know if you have any questions.